My name is Opeheim. I work as tech lead in the Norwegian consultancy company called Competence. And I'd be very happy to discuss all the issues I'm talking about today with you afterwards. So feel free to reach out to me for the rest of the day, or on Twitter, or use the Slack app to ask questions. So I'll spend some time to ask those at the end. So let's dive into it. Spaghetti code. What is spaghetti code? So, and what I mean by saying spaghetti code, okay, this is a bit unclear, but that's fine. Because spaghetti code is a bit unclear. Right? This is spaghetti code I could cover a couple of months ago. And what we can see with the spaghetti is that it's hard to see, first of all. It's unclear. It's a bit shady. And everything is really tangled, right? When you're cooking spaghetti, everything is tangled together. It's hard to see, is this spaghetti connected with that one? And so on. So the connection between different parts, they are invisible to you. You have to struggle a lot to understand it. And, well, I've worked with code that's like that. I guess many of you have as well. Does anyone of you not work with legacy code? No one not working with legacy code. Okay, great. Then you know what I'm talking about, probably. Right, so as we made something to, I don't like testing. Of course, what I mean by saying that is that I don't like manual verification. Coming to testing. So when I get a task, open or graphical client, click here, do this, do that, follow the recipe for how to test the same thing. Just step by step testing, so-called testing. I find that really boring. But on the other hand, I really don't like to cause bugs. Causing bugs is something, of course, I don't like that. No developer likes that. And I don't like these stressful periods right before you're doing a release, when you're fighting bug after bug, like a bit like playing the game Guacamole. When you're like putting down one and the next one pops up and so on. And fighting bugs sometimes feels like that. So I don't like either. And that led into the world of automated testing. And there's a precondition as well, that we as humans, we are creative, we are flexible, we know how to do things in different ways, we can improvise, we can do different things or what we initially didn't totally work out. While computers, on the other hand, they are stupid, they can't reason by themselves, at least not yet. And if they follow a recipe and the recipe has an error, everything crashes. But on the other hand, the computer is great at doing the same exact thing over and over again, without getting bored, without getting distracted, without losing focus. Because when I'm doing this test that I just spoke about, I lose focus after 5 minutes. My mind starts to wander. I'm thinking about football or what I'm having for dinner today or anything other fun, not the exact steps of the recipe. But luckily the computer is great at it, so let the computer handle the repeating boring parts. And that frees us as developers, testers, tech leads, all these roles to do more challenging, more fun, more exploratory things that add greater value to the things we're working on. So, how many of you are developers? Quite some. Then I guess you know this acronym try, don't repeat yourself. That's something every developer learns rather early. That if you're doing the same thing several times, you shouldn't duplicate the code. And that, on the one hand, while it's a rule of thumb that's pretty sound, there are some exceptions and such, but that's a different story. Let's not take that discussion today. But in the testing area, I found myself to be in a place or in a project where we tested the exact same thing over and over again, 3 or 4 times. Like the first test right after you did the task, then you had the system test phase, the acceptance test phase, and then production. And then we were doing the same thing again and again. And I started thinking, okay, so why don't we apply the principle of try to testing as well? introduction done, let's head over to the 9 ways to test your legacy code, or your spaghetti code. Just jump into the first one. Make a conscious decision on whether you test all or test small. And by that I mean, sometimes, or maybe most of the times, it's easiest to write a unit test. With a unit test you can control every dependency, you know exactly what you're testing. But on the other hand, sometimes everything is so connected and so tangled and just so spaghetti that in order to be able to test it, you have to test everything with a system test, integration test, whatever you want to name it. And both of these are fine. Both of these ways of doing testing are great. They're just great at different things at different times. So you need both. Yeah, set your dependencies from outside. Setters, constructors with parameters, or just field injection. So yeah, inversion of control. Use CDI if you can. So you can see an example here. We just inject the dependencies we need. So here's an example from our code base. And by doing that, you make those things something you can control in your tests. Like the dependencies from your class that we're looking at here. The dependencies are explicit, and we set them explicitly here so you can control them in your test. Yeah, so another example from a test class is that you can do things like that. Those words you don't understand are Norwegian, by the way, so don't worry. This is from a test I wrote a while ago. And you know those list manager, for example, that could be off, or it could be a real object, it could be whatever you want it to be for the sake of your test. Yeah, interfaces. Nothing new to my developers probably, but you need to start thinking about that as something that's important or that simplifies your tests. Because an interface defines the API of your class. Whenever you're programming, you're exposing an API to someone. Like you're exposing an API to either external or internal. You're exposing what methods are interested to call from outside in this class. So, on the other left here, you can see the implementation of a class, or like the methods that are in the class. You see that there are lots of methods. This is a small one. And whenever you see this thing, you might start to wonder, okay, what does this thing do? What does this thing do? What do I have to do to handle this properly? And what you're really not testing means this stuff, but it's just something that uses it, then it's so much easier to grasp this one, being with one single method. Well, I'm not going to take a hard stand either for or against singletons today. I know that's a topic that many people care a lot about. But if you are in a project that uses a lot of singletons, then you should know how to test them. And in a way, singletons can be fine for testability in the sense that, well, whenever there is a set instance, then that's obviously a place where you can inject or you can replace the code with your something you control in the tests. Like from the test code here, that we you set the instance, and then whenever the production code uses, for example, the session manager get instance here, then we're using the one we're controlling without doing any single changes to the production code at all. This is totally risk-free. But of course, there are some things to think about here as well. Because what happens if you run, like if you in your unit test set instance like this, and then you run double threading, so you run several tests at once. That both and two tests at once that both set to some instance. What happens then? Or what happens after the test and some other test just wants to use the regular session manager? What happens then? So you have to think of it about those kind of things, clean up the test. Package protect problematic parts. By that I mean, if there are some things that are difficult to test, extract it into its own method. It might sound simple or trivial, but it's one of those things that I use the most when I'm testing, right? When I'm testing my legacy code, or my legacy code, when I'm testing legacy code. Is this sort of this. And yes, it's an indication that, well, the code probably ain't division properly, or that there should be more classes, or there should be more. But, well, in legacy system, you don't always control the state as it is. Alright, so I've tried to do something I've done before, so live coding. So, okay, so I have some code interesting names here, like secret, or for example, when we're looking at your code, it's a bit smaller. Alright, now you can see, right? So we have this method called log method with much logic. Which is fun, but you can imagine it would be, right? In your production code, this would be long with much logic. And this one does some logic with a counter. So this counter should be a counter afterwards. And in the end, it opens a window with this counter. So when we're opening this window, it throws an exception. Because we shouldn't be opening a window here. So if I want to test this method, the log method with much logic, how would I do that? It's not cheat too much. Okay, so I want to test counter. We were the counter here one, right? We want that one to be pretty close to 100 when we're done, right? Counter should be 100, for example. So then we create a code class, like this, for the second. Legacy code class, and then we call that the log one with logic. What will happen when we call this one now is that it will throw an exception, right? Because we're trying to open a window, and we shouldn't be opening a window and then test it, because then obviously ISO will crash or anything like that. Yeah, so if you get an exception, of course we'll do it, because this one calls this real method. So here's a problem. If we test this, what I tend to do is pretty close to exactly this. I do extract method in IntelliJ. You can do this in Eclipse or whatever. Use manually if you want to. I make that method package private. So there's possibility of opening windows to delegate this method. And how do I do it? Why do I do that? Well, that's because in my test class, I can now say, okay, so whenever I try to open a window, do nothing. And if I run this test again now, then I probably also just learn something. Yeah, right? So that way. And one thing we ask by doing this report that we're not testing this method. We're not testing what's happening here. But on the other hand, so you should try to keep whatever happening in this method to be as little as possible from anything. Because these are things you, well, obviously don't test, but that's, at least we're testing this method now. So you can also, what you can do is, for example here, you can assert that, I think you can, go over this under. No, we tested that the counter is actually 100. So this is a small, tiny, dummy example, but you can use exactly the same ways of thinking with the weird production code. Yeah, another thing you can do is use Mockito. Has anyone used Mockito before? A couple of you. Okay, cool. I like Mockito a lot. It makes things like the things we just did much easier. It helps you to create objects that you don't entirely control your test that the objects that are really stupid and do or behave exactly what you tell them to do, but nothing more. And you can also verify so that you can, if you use Mockito on an object, you can ask the object, have you been called with this method or this parameter or everything like that. Which may be great if you want to do certain things like I just did. But of course you can overuse it. I've seen examples, I've done it myself, overused it, used it a lot. So if you're using very much Mockito in a test, then you should perhaps try something else like an integration test or some other object or whatever, do something else. But I tend to find that the more legacy the code base is, the more you make use of it. So we can just have a look at how this method with Mockito instead. So with Mockito we can say, when you're using an object, you can say, okay, so spy on this object. And spy actually means take the object as it is, but make it something we can explicitly tell how to behave. So it's a bit like subclassing, except that you can do, as we'll soon see, verify and so on. So Mockito has methods that do nothing. So whenever legacy code class is called call it open window with 100 as input, then do nothing. Mockito does. You can see it. So if you run this one now, yeah, because we don't verify anything. What we can do is actually use even verify. Legacy code class, we can verify that open window has actually been called with exactly 100 parameters. So this is basically the same test as we did a minute ago. If you were just to run private and only one, then it's there. Yeah. And you can do lots of things. You can say that okay, verify that this one has never been involved with this. Or it has been involved 8 times or whatever. So it gives you a lot of flexibility. It's a great tool. Finite or static. Again, if you like finite, if you like static, that's fine, but sometimes it might make the test harder to write. So then you might consider removing them. So let's have a look at an example here. We have this final method, which is public final method. So if we want to try to test this final method, and we have to be aware that this class is actually final. So we do use the same key trick as we just did, right? It's fine if you use something else, but do not mention when by the final method, right? So what happens now is that we run it. From side of the test, this should do nothing, as we call it, method with nothing. Try again. Of course, it does nothing because I'm nothing open with it. But yeah, and method is final, then for the exception, you don't need trying to run it, just remove it next slide. It is open. Cool. But if you remove final, even if you try to work it, yeah, and the same goes with static as well, exactly the same. So often getting coding test is a trade-off. Like if you like having a class of final, then you lose something by doing this, but the game doesn't really fit. So it depends what you need input. So in general, untangling is important when it comes to getting your code in the test. Because you're not as smart as you think you are. I'm not as smart as I think I am here. But as developers, we have a tendency to think that, okay, so there's complexity here, and there's complexity here, and there's complexity all the way between. But I'm smart, I'm a great developer, I know the program, I know the fixed problems, right? I know I can do this. So, okay, I can do all this at once, no problem. Yeah, so I fixed everything. And that's the way to go to get some bugs, at least in my experience. So the more we can separate things, the less things we as developers have to think about when we're programming, the better it is. The less we have to think about, the better job we're doing with those parts that we're actually working on. And if anyone of you are really into functional programming, or things from functional programming, then that also comes in here, like methods without side effects. That's great, right? You don't have to think about side effects. That's one thing that's less to think about. Or immutable objects. Great. That's one less thing that can fail. Yeah. So some of you might have been noticing that I've mostly been talking about ways to make your production code more testable, not that much about testing itself. And that is conscious in the sense that well-designed code tends to be more testable code. And code that uses principles like the single responsibility principle or the other solid principles tends to be better code than code that doesn't use it, right? And the code is better if you use inversion control, dependency injection. And if the code design is better if you have shorter methods or if you provide clear APIs. So all these things, I'd say, improve the design of your code base, but at the same time, it makes it more testable. So it's a win-win. Because you're testable through the system. There are two main approaches to making code, to getting fixed code on the test. And the one is the one that we're looking at now, to slightly improve the quality of the production code. The other one is to make smarter, more complex tests. Like you can use tools, Mockito as other versions of Mockito, which allows you to test final methods or static things and do everything in both private methods and like, lots of reflection models. I don't know if it still works after Java 9, 10, 11, but so you can make a lot of tricks to your testing code. But that's increasing the complexity of the system. If you do things that we've done now, I think it reduces the complexity. So it's more future-proof to improve your actual production code. But do as little as you can to get your code on the test. Like, say, I've used the term simple refactorings. My competitors use the terms safe refactorings. That is, do as little as you have to get your code on the test. So if you can do a refactoring that the IDE can do for you, that's probably fine. But limit it to the minimum you have to do. So that before you start big refactorings, or all the things that you really want to do once you see a legacy code base, right? Once you see legacy code base, the first thing you think is, oh, I want to rewrite this in a better way. Get rid of all the errors and scenario things that fail and pre-Java 6 code and so on. But get the code and test it first and then refactor it. Characterization tests. If you are unsure on how a method works, then you can use tests. Just write tests for the existing functionality. That will tell you how it will behave. So let's have a look at the example of that one. If we were to test this long method without this long method with much logic again, and we didn't happen to understand it when we did it. So then, what could we do in order to understand again what is called actually at the end of this? We could say, okay, so whatever we try to open the window with, do nothing. And then verify that the cover is 1. Because what will happen then when we run this test is that it will tell you what cover actually is at the end of the method. And if you do that before you start to change anything, more than you just did, then you go, oh, expected one actually was 0. Then you allocate the code as it is now, return 0 sorry, not 0, number. Then you learn something. Then you can, whenever you learn something, you can write that into your test, into a test. I have, for instance, learned today that the presentations need to be in combination with live programming as it is said today. Have your team. It's great if one of your team starts writing tests. It's even better if the entire team starts to do it. That's the only way it scales. And in order to accomplish that, you need to ask the question, okay, why are we writing tests today? What are the obstacles that make it without writing these tests today? And then you have to address the obstacles. And what those are might depend from team to team. It might be that you need to learn some techniques, or you need a new framework, or whatever. It could be lots of things. And of course, if you learn something, if you learn how to, okay, I'll do a test. I think that I'm actually working in school. Then of course you should tell it to the rest of the team so that they learn it as well. This one, tip number 6, we have been making this many times. We do have a continuous integration server running our tests often, and that mainly goes fine. Sometimes it fails. Whenever they fail, you should take action. Whenever the tests on your trying to develop master whatever your branch is, whenever they fail, take immediate action, fix it at once. Because if you let it fail for some time, then people start losing trust in the tests. So if you have one test that fails for, say, 3 days, then on the 3rd day, I can almost guarantee you that you have another test that fails. That maybe no one notices because it failed yesterday as well. But then we had 2 failing tests. comes for flaky tests. Flaky tests, those tests that are fine 9 out of 10 times but fail every now and then. They are also a way to decrease the trust you have in your tests. And if you can trust your tests, why not divide them with them? So fix those flaky tests or delete them, or just do anything to make it okay again. Right, feature toggles. For example, if something that do this, take this path, if not, take another path. This is an example of our code base where we have to be using swing front end. Don't do that either. But if we're in the headless, if your headless is a thing in Java where you say, okay, don't open a window. If you're trying to, the code is trying to open a window or waiting for user input from keyboard or mouse or anything, then throw an exception. So it's excellent for tests. Not so great for production code. So this is a path we have in the code. So feature toggles can be like anything that says if this doesn't do this, if not, do something else. Yeah, you can have properties file that says if production, then pay salaries, if not, pretend to pay salaries, or any other way. And in your tests, you can make use of this as well. Or you can use something like FFJ or module someone that looks what's up there. Yeah, one test and have several test classes. By that I mean, if you have a long production code legacy class that's, say, 2,000 lines long, we have that, I made that. And which does 4 different things. Like it does both some banking and some finance and some loans and so on. Then you can perfectly fine have one test class for loans and one for banking, right? You can have several test classes even though you have one production code class. And I can also point you further on, when you are later on going to refactor, if you have one test that's on loan and one that's on banking, then it's obvious to you that, okay, perhaps I should try to divide this production code into banking and loan. And of course, the other way around as well. You can test one class through a class that uses it. Yeah, but I encourage you to do everything one line at a time. That means do small refactorings are better than no refactorings. Small improvements are better than no improvements. And if you every time you change your code, you improve the code base just a tiny bit, then eventually everything will be good, or at least much better. And as a bonus though, this is also something, if you improve, it's part by part, every time you do something, then no product manager will say, okay, we can't do this, but we do some other thing instead. Or you can't postpone the improvements. So you can't increase technical debt because it's always, it's always a new feature that someone wants. So if you say, okay, we need 2 weeks to get rid of technical debt, chances are some manager or product owner will say, no, we have to do this instead. But if you continuously improve the code base just a tiny bit, no one will stop you from doing that. If no one tries to stop you from doing that, get something else to do. This is also another benefit is that this is safe, right? If you do a small tiny improvement, then you continuously have a code base that's working. If you do a big refactoring of several weeks, then you might have something that works, might not have. Who knows? That's a risk. Yeah, but refactor in separate commits. I see that when I do QA, when they review someone else's code, it's so much easier to review it. What is new is separated from what is just refactoring. So reviewer will be very grateful to start doing this or continue doing this. Okay, so time flies very fast. TDD. I really like TDD. Why do I do it? Because it makes me write much better tests. It makes me write tests that focus on what are we trying to accomplish, rather than how is it accomplished. So test-driven development, right? You should write the test first, and produce the code afterwards, and then you refactor, and so we go. And what's great about this is, yes, it makes you write better tests, but it also makes me think, what am I trying to accomplish? And it makes me actually write easier code. Because when I'm having to write the test first, then I'm not making up so much stuff. I'm not making the hard APIs, the methods with 8 parameters. I'm not making all this love stuff. I make it so much easier. And it gives me immediate feedback. You saw the time of running the test here, it's short time. And you get things done. Because that's one of the things that many developers struggle with, or development teams struggle with, is like taking a task from almost done, all of the stuff that are almost done, I just have to move them into done. So Kanban tries to address that, but TDD also in a way addresses that. In the sense that, okay, so now I already test for this part is completely done, now what the next part, and so on. So, testing great spaghetti. Just a spaghetti, what do you do when you try to write or handle legacy code with test-driven development? I'm thinking a lot about this, and really, I think it boils down to you have to get your legacy code in the test, and you have to do test-driven development. So doing TDD and spaghetti code is pretty much doing those two same things. Nothing more to it than that. I think, because I'm doing this all the time, I'm really trying to think what distinguishes doing TDD on spaghetti code from doing TDD on code kernels and so on. I think the only big difference is patience. You need to have a lot of patience. You need to be patient that you test everything first all the time. You need to keep going. Even those times when you meet code that's hard to test, you need to keep going. But this doesn't really separate it from testing legacy code afterwards. So if you do it first or you do it afterwards, it's pretty much the same. In that sense. So if you work on legacy code and want to get started doing TDD, what do you do? To be honest, I think there's some ways to do this. I don't really remember how I got started. But maybe watch some videos, try some code kernels, or just try it. And then if you've got a bug that you've got to fix, try writing the test first. If you're going to do a bug fix on a method that's existing, start off by trying to write a test for that method, and then do a fix. Right. Tip 10, 11, and onwards, like other things I've learned when we try to get legacy system on the test. If we go fast on this one. Limiting beliefs. Of course you can do it. One of the beliefs is something. Because when you're in a code base for a long time, or in a project for a long time, you start to get this belief that, oh, I can't do that. And you don't really know why you think that, but it's just that's the way it is. So challenge whatever limiting beliefs you have. Of course you can do talk on a conference, of course you can write better code, of course you can. Why can't you? Yeah, you will forget things. When you write code now, you will forget how you did it. In 2 years, you're going to forget everything, right? Happens to me all the time. Just keep that in mind, someone's going to come back to the code. Might be you as well. And if you then write the code with great tests, well, you won't screw it up next time you see it. You will stupid things. That's okay. Perfectly legit. As long as you learn from it. I did that as well. Stupid tests all the time. But I think they're better now than at the beginning. Yeah, be consistent. So just keep working. But do it easier to write. Like, if you solve a problem writing tests now, do it easier for the next one with whenever they kind of encounter the same problem, make it easier. So learn, we'll keep learning in the team. Right, so we're closing in on 45 minutes. So for those who want to learn more, what do I recommend? These two books. Working better with legacy code, like the brothers. Great resource. Refactoring Martin Over was a classic as well. Just came in a new version. I haven't read the new one, but the old one's great. Lots of practical tips. Still relevant 20 years after. Or head on Twitter. So the test community is very active on Twitter. So I've just dropped on the hand here, Basic Crispin, Basic Funky, Ninja Jones, Mullet Behavior. There are lots of great test groups on Twitter. I learned a lot from that. We would have time for bonus track. Depending on you are very interested in the difference between technical and business domain, reach out to me afterwards. So the key takeaways for this talk, I think, the good code design improves testability. TDD as a spaghetti show is mainly just TDD combined with testing spaghetti code. Go ahead and write tests for legacy code. You can do it. Do we have time to answer some questions?
Yeah, it's like just you need to open a URL that
yeah, I think it is.
Just I'll give some explanation. Arkadaşlar her session'da en çok evet benim ismimi görüyorsunuz orada ben kimse yazmadığı için soru yazmışım. 2 tane kitap hediye ediyoruz en çok oy alan sorulara. Ben almayacağım. Benden sonraki arkadaşlar soruları yazarsa en çok 3 soruyu okuyacağız cevaplanmaları için. O 3 kişiye de kitap hediye edeceğiz. Yeah, you can start for the first question.
Well, yeah, that's a great question. I wish I had a great answer, to be honest. I don't have much experience with that, so I don't have a great answer. I'd start asking on Twitter. Mock stuff. My experience is that people use this a bit interchangeably, but it's just a way for mock stuff. Well, pretty much the same, I think. I think that needs a longer answer. You guys have to ask good questions. Should we consider refactoring to write the test for legacy code? Yes, but write the tests first so that when you are refactoring, you know how it will behave before you start it. So you can ensure that behavior afterwards is the same as the behavior before. So consider doing one thing at a time. So I find that whenever I do TDD like strictly, so it's tiniest little thing that has to go and then fix it, then I do rarely make errors at all. Whenever I'm bunching up and doing several things several lines at once, then I do get the risk of failing. So just at least in the beginning, I think it's smart when you're trying to learn TDD to do very small steps. And then you can adjust the steps a bit. Of course, it depends a bit as well on how complex the code is, right? Some methods are really hard, and some methods are not that hard, so we can actually read them and get what they do. And once you understand it, you probably can do more at the time. Should we test the for us? Yes, is the answer. I think you should do both, in the sense that I think you should write tests so that you after that you're grading what you think you are grading. And then someone else should test that actually what you thought you graded was what you were supposed to be grading, or what the business needs. Hopefully you know that as well, but it's always great to have some fresh eyes on both your code and the result of your code. So when writing tests like this, I suppose I would suggest that you do it yourself, or maybe pair programming code for very. But then that's the top level. Okay, so time is running. Whoa, this is always possible for very good classes. Probably not, but I've seen very few cases where you can't, or there are some cases when it doesn't really make sense. And if something doesn't make sense, then don't do it. That's a good rule of thumb in general. But say for 95% plus, then I think it's perfectly possible to write a good test. As in my experience in Java, might differ from languages.